Good morning, everyone. Hope you are doing well. Your days are going productive and you are doing excellent in your studies. So, we will be starting the next session. In the last class, we have seen the basic things, the syllabus basically, the contents which I am going to cover in this course. And after that, we have seen some historical events, chronological events in the history of quantum mechanics. Now, as I said earlier, that in this lecture we will be studying or we will be looking at mathematics involved in quantum mechanics. In entire quantum mechanics, there are so many integration, differentiation, these are involved. So, just to make you recall that, okay, I will be writing formulas involved in this. Okay, first, formulas of differentiation. Differentiation. For you this may be very basic, or this may be very basic to you, but I will request you that in your notebook you write each and everything I am writing on the board. Okay, first, d dx of x to the power n, it is basically n x to the power n minus 1. d dx of any constant a, any constant, that is basically 0. C, d dx basically a function of a function of x, a function of x, and when the value of x is given, that ultimately leads to a constant, that is also basically 0. Sorry, that is also basically 0. One thing. Sorry. Okay. Function of x, when the value of x is given, that is basically 0. But when a function of x, the constant is not given, that means the value of x that is not given, that is basically not equal to 0, right? A function which contain x and value of x is given as c, then you can just put the value of the x in the equation, and that will lead a constant. So its differentiation basically it will be 0, and if it is the constant value is not given, then it will be not equal to 0. 3, 4, d dx of a x to the power n, the constant will be outside a n x to the power n minus 1. 5, d dx of multiplication uv, first u, then dv dx plus v du dx. 6, d dx of sin x. Now you can say that what will be u by v, then you can do it, you can consider it as u into 1 by v. There are two different functions, so first u and derivation of this, differentiation of this, plus 1 by v plus differentiation of u. Okay, sin x, it will be cos x, d dx of cos x will be minus sin x, d dx of e to the power ax, a is constant, is basically a e to the power ax. 9, d dx of e to the power ax square, basically we will be writing e to the power d dx of e to the power x, basically it is e to the power x, but here e to the power something, that will be exactly e to the power something into differentiation of this function. into dd x of ax square, that will lead to 2ax. ddx of ax square is basically 2ax into e to the power ax square. Okay, so this is basically the basic formulas of differentiation that we are going to use. Next we will be looking at formulas of integration. One, integration of x to the power n dx equal to x to the power n plus 1 divided by n plus 1. 2, there will be always there will be constant if there is no limit, but I am not writing the constant. Okay, just we need to know the formula. Integration of sin x dx, that is basically minus cos x. 3, because in actual application of quantum mechanics there will always be limits. Integration of, if there is sin a constant x ax dx, then minus cos ax by a. In differentiation that is basically multiplied, and here it is divided. 4, integration of cos x dx equal to sin x. 5, integration of dx upon x equal to ln x. 6, integration of uv dx equal to u integration of v dx, u integration of v dx minus du dx integration of v dx dx. This is a little bit difficult. Okay, so differentiation integration is complete. Now let's go to trigonometric functions. Trigonometric basic 1-2 formula we just have to recall, which we generally forget. Okay, and we have to use that. Sine 2 theta means 2 sine theta cos theta, 2 sine square theta means 1 minus cos 2 theta, 2 cos square theta means 1 minus 1 plus cos 2 theta. Okay, now one very interesting thing, cos. First let's take sine of n pi equal to 0. When n equal to 0, 1, 2, 3, anything, that means 0, sine 0 equal to 0. Sine 1 pi, that means pi is equal to 0, pi means 180 degree. Then sine 2 pi is equal to 0, sine 3 pi equal to 0. Now sine, if it's pi by 2 comma 5 pi by 2 comma 9 pi by 2 and so on, these things, sin pi by 2 equal to 1, sin 5 pi by 2 equal to 1, sin 9 pi by 2 equal to 1. Sin, if it's 3 pi by 2, 7 pi by 2, that means 4 is adding on, and 4 is adding on. Okay, or 11 pi by 2 dot dot like this. If sine 3 pi by 2, that means basically these are basically minus 1. So these are value of sin x at different locations of the graph of y equal to sin x, right? Now cos n pi equal to 1 when n equal to 0, 2, 4, 6 like this. So sin even pi equal to, sorry, cos even pi equal to 1 and cos odd pi equal to minus 1 when n equal to 1, 3, 5. So cos even pi equal to 1, cos odd pi equal to minus 1. Okay, got it. So if we just draw the graph of sin x, that will be this. This is basically 0, that is basically pi by 2. What is the value of pi by 2? Sin pi by 2, sin pi by 2 basically 1. So sin pi by 2 basically it is the maxima, it is value of 1. And when it will be minimum, that is minus 1, that was 3 pi by 2. That means this location is 3 pi by 2 and this is basically minus 1. So the midpoint of pi by 2 and 3 pi by 2 is pi, right? So this goes like this. So this point will be 2 pi, right? And similarly the cos graph propagate like this, y equal to cos x. This is basically 0, this is 0, this is plus 1, this is minus 1, right? So plus 1 when the cos value is plus 1, sin when the cos value is plus 1, n equal to 0, 0, yes, 0. When the value is 0, that is basically plus 1. When it is minus 1, then n equal to 1. When n equal to 1, that is the cos value is minus 1. So cos value is minus 1 when n equal to 1 means n pi, that is pi. So this is basically pi. So this point is basically pi by 2. So these are very basic thing about sine and cosine graphs. And just if you in case you forgot the values of sine theta at different degrees, for example 0 degree, sine 30, sine 0, sine 30, sine 60, sine 90, 0, sine 0 is equal to 0, sine 30 equal to 1 by 2, this is equal to 1, sorry, there is 45, 0, 30, 45 is basically 1 by root 2, then sine 60 is equal to root over 3 by 2, then sine 90 is 1. Cos theta will be exactly opposite, reverse, 1 root over 3 by 2, 1 by root 2, 1 by 2, 0. Tan 0, 1 by root 3, 1 root 3, 0. No, 1 should be infinity. Tan theta means sine theta by cos theta. If theta equal to 0 degree, then sine 0 by cos 0. Sine 0 means 0, cos 0 means 1. So that is basically 0. Okay, so that means 0 is equal to 0, it's fine. If it is 90 degree, then sine 90 by cos 90. Then sine 90 value is 1, cos 90 value is 0, that is this will be infinity, sorry, this will be infinity. Okay, now one or two special formulas are there which we should know, and in quantum mechanics they are very much used, and you have to just memorize this. For example, if there is integration of sine square bx dx equal to 1 by 2 x minus 1 by 4b sine 2bx. If there is cos square, b is basically constant, because For example, sin square 3x dx or sin square 9x dx, if this kind of integration comes, bx dx cos square, for cos square it will be half x. And how I am writing this, because if there is limit a to b, then there will be limit a to b, and thus we have to calculate, plus 1 by 4b sin 2bx. Now r to the power n e to the power minus alpha r dr. This will be very much useful in quantum mechanics, this derivation. This will be, answer will be factorial n by alpha to the power n plus 1, factorial n r to the power n e to the power minus alpha r dr equal to factorial n by alpha to the power n plus 1. This is very important. So these are basically basic formulas which in quantum mechanics we use. Now in the next class we will be studying operators and functions. We will be studying operators and functions. Operators and functions. You know, few initial lectures maybe you may feel a bit boring, but trust me, be with the course and you will be learning, you know, much more better than your peers. Thank you. Have a nice day.